Welcome back everyone to another video. Today we're going to see how to integrate a quadratic equation. Up to this point, we have encountered several integrals that involves quadratic expressions, for example, integrals of the following general forms. We also learned how to evaluate integrals involving expressions such as thus. Now by using trigonometric substitution. However, all of those integrals involved only the quadratic term and a constant. There was no linear term in x. In general, integrals involving a full quadratic expression of the form like this, and it required different approaches. Some integrals involving quadratics can be simplified by substitution if the numerator is a multiple of the derivative of the denominator. If we let this, then that, so an integral of this form can be evaluated as the final result. If the quadratic is in the denominator, it can be factored into linear terms. We can apply partial fraction decomposition. For example, if ax plus bx plus x is p1x plus q1 and p2x plus 2q, then the integral can be written as this and decomposed into separate simpler logarithmic terms. And that's it guys, thank you for watching and please don't forget to like and subscribe for more.